Good day. I am Trisha Ann Santos, and on behalf of Group 7, I am here to present the demonstration of our working program. As you can see, the program that we created is a polynomial calculator, and it can calculate a polynomial with a maximum degree of 5 using 3 methods, namely bisection, Newton-Raphson, and second method, as you can see here. So the input areas are where the user is tasked to encode the guess values, the terminating error, and the coefficients for the main function, and for the Newton-Raphson method, the differentiated function coefficients, as well as the x values that will be needed to plot the graph. And the output area is where the number of iterations, the root, and the absolute error is displayed. Additionally, these y coordinates are also shown as the output. As you can see here, no formula were written in Excel. There are some validations that are present in this program, like if there is no method selected from the choose method box, like this, for example. Yan. Okay, so a message box will pop up and the code will not run. And other validations, for example, if for the Newton-Raphson method, if no coefficients are written here for the differentiated function, the code will not run. But then, this will not affect the bisection and the second methods. Another is, for example, if there are no initial guesses placed here, and for the terminating error, the code will also not run, and it will only pop up this message box that says that cells cannot be empty, and please choose a method to find the roots and fill up all the required field. If no input is required, put 0. So the user will put the initial guess for the Newton-Raphson method here on the first cell, and for this part, the user is required to put 0 in order to make the code run. The compute button, as the name suggests, will get the root of the polynomial function using the method chosen, and then the results will be displayed here. So to test the compute button, I will use different points for each method, and let's start with the bisection method. So I will be inputting the required information for the bisection method, and I'll be right back. Okay, so the required information for the bisection method are written in their respective areas. So we can now use the compute button. Here, I'm gonna click it. So as you can see, the output is terminated at 15 iterations with the value of root at 0.062456, and this is the absolute error. Okay, so this is less than the terminating error. As you can see here, for the bisection method, even if you don't place anything here in the differentiated function coefficients, it will not affect the bisection method. Okay, so now that we are done for the bisection method, the reset button, as you can see here, will clear the contents for both the inputs and the output areas. So yeah, we're gonna do it now. There, as you can see. Now let's proceed to the other methods. Now we're going to do second, so I'm gonna input the required. Okay, so now we are done with the required information for the second method. We can now compute for the root of the polynomial function written here. Okay, so let's press compute. There, as you can see, it terminated at 5 iterations. This is the value of the root at the termination, and this is the absolute error. Let's proceed to the last method. I will input the required fields and I'll be back again. Okay, now, so the required input fields for the Newton-Raphson is somehow written. Yeah, as you can see, we can now compute. As you can see, earlier we did not put anything here for the bisection and the second method, but then for the Newton-Raphson method, it will not work. As you can see, let's read. Cells for the differentiated function coefficients cannot be empty for Newton-Raphson method. If no input is required for a certain cell, please put 0. Okay, so now that you have seen the validation for that in Newton-Raphson method, I will now put the required differentiated function coefficients here and I'll be back again. Okay, so now that everything required for the Newton-Raphson method is written, we can now compute for the root. There. As you can see, the iteration terminated at 7 iterations. This is the value of the root and this is the absolute error. For the last part of our project, the graph button here will show the graph of the equation that is written here with the given x values from the user. And as you can see here, there's also a validation for the graph button there. Please enter the x coordinates in order to graph the polynomial function. So now I will put the x values. So if the graph button is pressed, all the y values will be presented here and then the graph will be completed. There. So using this equation and these x values, the graph of the function is this. That's all for the project phase 2 of group 7. Thank you for listening and watching. Bye.